Hello and welcome to Maths with Mr Amison. In this video we're going to be practicing finding and using the formula for direct proportion. I know this is quite a tricky topic. If you haven't done so already, then it's useful to watch the learning video about this done by Mr Chowdhury. Okay, so I'm going to start off by showing you some examples. I'm not going to talk while I go through it. Then once the answer's on the screen, I will talk through it so that you can see why I've done what I've done. Then you can pause and have a go yourself. Okay? So for question 1, y is directly proportional to x. Whenever we have two quantities that are directly proportional to each other, we can write it like this. This symbol here is the proportionality symbol. Often students like to call it the fish symbol, but it means is proportional to. So y is proportional to x. Okay? So here, that proportionality symbol means that as y increases, x increases equivalently. It increases by the same factor, or in other words, x and y are linked by a factor. So we have y is equal to something times by x. It means x and y are in the same ratio, basically. So we can write, instead of the proportionality symbol, we can write equals k. So here, if y is proportional to x, we can write y equals kx. Now, we were given in the question that when y is equal to 105, x is equal to 75. So I can replace the y and the x with 105 and 75. I know it says kx and I've put 75k, but because multiplication is commutative, it can happen in any order. Kx is the same as xk, and generally we write the number in front of the letter whenever we are multiplying algebra by a number. So we write it as 75k. So here we have 105 is equal to 75k, and we can then solve that equation to find the value of k. We end up with k equaling 1.4, at which point we should notice that our original formula, y equals kx, has the letter k in, which can be replaced with the value of k that we just found. The difference between the original general equation and the value of k being 1.4 here from 105 and 75 is this is a specific case. In this specific case, y is equal to 105 and x is equal to 75. But k in this specific case is the same value as in the general case, where y equals kx. So we can replace the k in the general case with the k in the specific case. So we get y is equal to 1.4x. Then we can use that fact, the fact that k is 1.4, and we've got our formula for y in terms of x, we can use that fact to determine the value of y given that x is 175, because we know that y is 1.4 lots of x, so 1.4 lots of 175 in this case, to give 245. So now I'm going to show you question 2 and then talk through that one afterwards. So this works in a really similar way. We have y is proportional to x squared. So we can replace the proportionality symbol with equals k, where k is a constant that links the two. Y is something multiplied by x squared. Alright? In this specific case, when y is 27, x is equal to 6. So we could replace the y with 27. We can replace the x with 6. When we replace the x with 6, x squared becomes 6 squared, which is 36. So we end up with 27 equals 36k. Then we can solve this equation to find our general value for k, because k is a constant, it never changes. So we can find that value. If we divide both sides of our equation by 36, we end up with 3/4 on the left and k on the right. Notice that it's okay to have a fraction here. That's not a problem at all. You could have left this one as a fraction if you wished, or changed this one to a decimal. It really doesn't make any difference. It still works. So in this case, we substitute in k is equal to 3/4 into our original equation here, into our general case rather than our specific case. And we end up with y is equal to 3/4 x squared. Once we've got that, find the value of y when x is equal to 4. So y equals 3/4 multiplied by 4 squared, because we have to remember that the x is still squared. Okay, x is squared throughout this entire question because that's what it says at the start. That's a really common problem that some students have, forgetting that x is squared. So 3/4 multiplied by 4 squared, or 3/4 multiplied by 16. 3/4 of 16 is 12, so y is equal to 12 when x is equal to 4. Alright, take some time to copy that down, make any notes that you need to, and have a go at the questions on the right. Now you've had a chance to have a think, let's go through these. Y is directly proportional to x, so we can write the proportionality equation again. Y is proportional to x. Y is equal to 75 when x is equal to 105. This is similar to the first question on the left, except I've swapped around the 105 and the 75. So we still have y equals kx because we replace the proportionality symbol with equals k. Then we can have a look at what happens in the specific case of when y equals 75 and x is equal to 105. In that specific case, 75 is equal to 105k. Then we can divide both sides by 105 and get k is equal to 0.625. Again, it's okay to put 5/8 there, that's not a problem at all. Then we notice that we have k in our general formula and we can replace it with the 0.625. So y equals 0.625x. Then to find y when x is equal to 176, we can then do y equals 0.625 multiplied by 176 to get our answer of y is equal to 110. For question 2, this time y is directly proportional to the cube of x. Now you have to be careful when you've got these questions because it does say the cube of x. It may not have the mathematical symbol of x cubed there, but it says it in the question, so y is proportional to x cubed, not just x in this case. If y is proportional to x cubed, our general formula, if we replace the proportionality symbol with equals k, y equals kx cubed. Then to find the value of k, we need to look at the specific case. When y equals 27, x is 6, x cubed, then 6 cubed will be 216. So if we divide both sides by 216, we get the value for k being 1/8, which we can then substitute into our original general case, and we end up with y equals 1/8 x cubed. Then to find y when x is equal to 4, well, y is equal to 1/8 of 4 cubed, or 1/8 of 64. 64 divided by 8 then is 8. So here are 6 questions for you to try. Question 1 through 3 are fairly standard. Question 4 gets a bit trickier, and question 5 and 6 you really have to think a bit about what you're doing, so be really careful with them. Alright, pause now, have a go. Okay, so here are the answers to those questions. Y is directly proportional to x. Find a formula for y in terms of x for question 1. So we just need the formula. So when y is 12, x is 3, y equals kx. If you remember, if we replace the proportionality symbol, we find the value of k to be 4, so we get y equals 4x. For part B, y equals 8 when x is 16, so y equals kx again. Y is k lots of x, so y is half of x, and you can see that quite clearly from the example that we have there. For question 2, b is directly proportional to a, so b, then the proportionality symbol, then a, so b equals ka. If we replace b with 10 and a with 8, we can get the value of k to be 1.2 or 6/5. And then we need to find the value of b when a equals 13. So b would then be 6/5 of 13, which is 16.25 or 16 1/4. For question 3, this time y is proportional to the square of x, so y equals kx squared. If we replace the x and y with 4 and 8 for the specific case, then we end up with k being 1/2 or 0.5. So we end up with y is equal to 1/2 x squared or 0.5 x squared. To find the value of y when x is 3, we need to do 1/2 of 3 squared, or 3 squared is 9, and 1/2 of that is 4.5, so y is 4.5. For question 4, n is proportional to the square root of m, so n equals k times by the square root of m, so k root m. We can get the value of k to be 4 in this case when we use the specific cases of m equaling 4 when n equals 8. And then we can use that to help us find that n is equal to 12 when m is equal to 9. For question 5, b is directly proportional to the cube root of a, so b equals k cube root a. We can use the specific case of a being 27 and b being 4.5 to find the value of k to be 1.5. So we get b is equal to 1.5 cube root a. Now to find the value of a when b is 7.5. So this one's a little bit different because we are given the value of b on the left to this side instead of a on the right. But we can still calculate this the same way. We just have to rearrange and solve this equation to find the value of a. So if we divide both sides by 1.5, we get that 5 is equal to the cube root of a. And if we cube both sides to undo that cube root, we get that a is equal to 125. For question 6, this is really tricky using algebra generally. Y is proportional to the square of x, directly proportional to the square of x. So y equals kx squared. Because we have a and b, we need to replace x and y with a and b. And we need to find the value for k in terms of a and b. And we get the value of k in terms of a and b to equal b over a squared. So y is equal to b over a squared x. But then it says to find the value of x when y is equal to c. So we can say that c is equal to b over a squared x squared. Remembering to have x squared there because it's directly proportional to the square of x. Then we can rearrange this. We can multiply both sides by a squared to get ca squared is equal to bx squared. Then we can divide by b to get ca squared over b is equal to x squared. And then we just have to square root both sides to get that x is equal to the square root of ca squared over b. Bear in mind that that x could be either positive or negative, because if x squared is equal to a number, then x could equal the positive or negative square root of that. Something to be careful of when you're doing things like this. Usually it will be pretty obvious whether you need the positive or negative version, or whether, if it's really general, write both down anyway, just to be safe. Thanks for watching. I hope you found it useful. I know this is a tricky subject. Bye for now.